This video, we're going to conclude the factoring series with this method that used to be called the trial and error method. And the trial and error method was basically what it sounds like. You try it and you're wrong. Then you try it again, you're still wrong, and then you try it again, and now you're right. So you basically would guess, and then as you did more and more of the problems, you got to be a better guesser. So maybe you didn't have to try it too many times, but I've done them. Well, I remember when I first learned them, and I'd have to try like 5 or 6 times. So the trial and error method was kind of appropriate for a title. Then later on, they started coming up with this. Some people call it the front times the back, the A times C. There's various names for it where it doesn't have a lead coefficient of a 1. It's not something recognizable like the sum or difference of 2 cubes or squares. It doesn't have a square on each end like a binomial square might have. It's not factoring by grouping. So if it's a trinomial and it doesn't seem to fit in any of the other characteristics, you try this method, all right? Whether it's called A times C or whatever. And if you're a good guesser, you could always do the trial and error method. All right, now let's look at this first problem. All right, and you would go, okay, there's it's not a lead coefficient of 1. It's not a difference or sum of 2 squares or cubes. It's not got a square on each end. Nothing in common to factor out or anything. So I think it's the A times C method. Remember, this comes from, they call that because the form for quadratic is ax squared plus bx plus c is where the quadratic formula comes from. So a is what multiplies the x squared term, b is what multiplies the x term, and c is constant. So if you had something like this that did have a lead coefficient of a 1, you would say what multiplies to the constant, the n number, and adds up to that middle term, which is b. So what multiplies to c and adds to b? Well, instead of multiplying to the n number and adding to the middle, what we're going to say is we're going to take this 2 times this negative 12. So 2 times negative 12 is negative 24. And then we're going to say what multiplies to negative 24 and adds to negative 5. So it still adds up to that middle number, but instead of saying what multiplies to 12 and adds to 5, we're going to take this front number, this back number, which is A and C, multiply them together and say what multiplies to 24, negative 24, and adds to negative 5. Well, the factors are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now, if they multiply to a negative, they're different signs. One has to be plus and minus. And I add to a negative 5, so I have more negatives left at the end. So I just want to show you something. All right. So if you look at what these add to, this adds to negative 23. This adds to negative 10, so I'm getting closer to negative 5. This does actually add to negative 5, and this adds to negative 2. So do you see how I'm getting closer to the number I want and then pass it? Okay. So if you're skipping around like with a big number, like if you had 124 and you're looking for all these possible factors, sometimes you can skip sections because you'll end up, but if you pass it and you've gone to negative 2, you go, okay, it's in that section I just missed. I got to back up and find those factors. Now, this method works so well that if you pick the wrong factors, if you'd gone in here and say picked these two, you're going to get 2 binomial factors, but they won't be the correct ones because they won't add up to negative 5x, they'll add up to negative 10x. So be sure, absolutely sure, that you're picking the right pair because, like I said, it won't stop, it won't snarl up and kind of just come to a halt. It's going to give you 2 lovely looking binomial factors, but they're the wrong ones. They'll be the ones that add to negative 10x. So I'm sure, I'm absolutely positively sure that 3 and negative 8 add to negative 5x. Okay, so we've got my numbers, and I'm going to stretch this kind of like a rubber band, and I'm going to move these apart. And I'm going to replace this minus 5x with these numbers that I found, a plus 3x and a minus 8x. All right, so you're going to stretch this pair, add in this variable that you're trying to add to, and kind of stretch that out in the middle. Then you're going to do the factoring by grouping technique, which is in the previous video. So you say what's in common in the front 2 and x. What's in common in the back 2? A minus 4. And that would leave you 2x plus 3. If factoring by grouping, if you just came across this video, there's a link in the description to the previous factoring by grouping technique. So what's in common in the front and the back? 2x plus 3. And that would leave you x minus 4 from here and here. And if you multiply those out, you'll see that you had the correct answer. Now, just to show you, it doesn't really matter if you had said 2x squared minus 8x plus 3x minus 12. If you write these down backwards, okay, from the way somebody else might write them, you would say what's in common in the front 2? A 2x. And that would leave you x minus 4. What's in common in the back 2? A 3. And that would leave you x minus 4. What's in common in the front and the back? An x minus 4. Bring down the 2x. Bring down the 3. Now, so it's the same factors. The only difference is the order, but you know that 2 times 3 is the same thing as 3 times 2, right? When you multiply. So it doesn't matter if it's 2x plus 3 times x minus 4 or x minus 4 times 2x plus 3. Both of those are correct. Let's try 15x squared minus 23x plus 6. There's nothing in common to factor out. You should always ask. It's not one of the previous types that we've covered. So this is the a times c. So we're going to take 15 times 6 is 90. And it multiplies to a plus 90. Right? So it multiplies to plus 90. But we want it to add to negative 23. So if it multiplies to a positive and adds to a negative, they both have to be negative. All right? So here we go. We'd have 1 and 90, 2 and 45, 3 and 30, 5 and 18. Right, now these add to 91, 47. See how we're getting closer? 33. That's 23, right? But for it to be a negative 23, these both have to be negative. So let's check. Does negative 5 times negative 18 give me positive 90? Yes. Do they add to negative 23? Yes, because remember, if you pick the wrong pair, you'll get two lovely binomials, but they'll be the wrong ones. So we scooch this out, and we take our minus 5, and we use this variable, minus 18x plus 6. All right? What's in common between 15x squared and minus 5x? 5x. So that would leave you 3x minus 1. What's in common between minus 18x and 6? Negative 6. Remember, we're going to use this sign right there. 3x minus 1. Also remember from the previous video, if you'll just take a few seconds and multiply this back out and see that you didn't lose a sign or do an incorrect factoring, that will save you much pain. All right, what's in common in the front and the back? A 3x minus 1. Bring down the 5x. Bring down the minus 6. And that's your solution. Okay, let's try one that's a little bit more complicated. All right, now you try this one. Okay, so stop the video and try this one and see, get an answer, and then restart the video and see how we did. Compare. So you work this one. Okay, now hopefully you're back and you looked this over and went, well, it's a trinomial. It's not a lead coefficient of 1. It's not anything like that there. Oh, is there anything in common? there is a 3 in common. So did you get the 3? All right, I'll talk to you about if you didn't get the 3 in just a second. So you would say, okay, I have this 3, let's not forget it, right? Now, I'm trying to factor this some more. So 6 times 15 is 90, just like what we had before. 1 and 90, 2 and 45, 3 and 30, 5 and 18, 6 and 15, 9 and 10. Whoops, that's supposed to be a 10. So this multiplies to 90 and adds to 19, but I wanted to add to a negative. So they both have to be negative to multiply to a positive 90, add to a negative 19. So we're going to stretch this. Minus 9x minus 10x plus 15. What's in common in the front two? A 3x. 2x minus 3 is what's left when you factor that out. What's in common in the back two? A minus 5. And that would leave you 2x minus 3 in this back two. What's in common in the front and the back? Bring down the 3x. Bring down the minus 5. Did you get that? Okay. Now, if you saw that 3 in common, which we need to write down. Keep it on going down here. All right. That turned out to be not so bad. If you didn't see the 3 in common, you would say 18 times 45 is 810. And you would say what multiplies to 810 and adds to negative 57. All right. So you would start off with 2 goes into it 405 times, and then you could, skip down through this, all right, until you found out that it was 27 and 30. All right, which took a lot of work. So when you found out it was 27 and 30, and you would have 18x squared minus 27x minus 30x plus 45. What's in common in the front two is a 9x. What's in common in the back two? Minus 15 times 2x minus 3. So then you would say, what's in common in the front and the back is 2x minus 3. Bring down the 9x and the 15. Now, if you boxed this in, this would be slightly wrong. It's mostly correct, I guess, but it's still slightly wrong. And you would say, well, there's nothing in common between 2x and 3, but there's still a 3 in common between 9x and minus 15. So you would have your 2x minus 3, factor out a 3, and that would leave you 3x minus 5. So you would have your 3, 2x minus 3, 3x minus 5. But the work to get through all these factors to find 27 and 30 is much harder than the work to find the common factors in 90. So it's always to your benefit to try to factor out anything that's in common. All right, let's try one more. 5x squared minus 22x plus 21. Is there anything in common to factor out? No. All right, so 5 times 21 is 105. Positive. What multiplies to 105? 1 and 105. 2 won't go into it. 3 goes into it 35 times. 4 won't go into it. 5 goes 21 times. 6 won't go. 7 and 15. And 7 and 15 will multiply to 105 and add to negative 22 if they're both negative. So then we will have 5x squared plus 21. And we're going to stretch this minus 7x minus 15x. And this, I stretched a little bit too far, plus 21. What's in common in the front two? An x. What's in common in the back two? A minus 3. And that would be minus 15x divided by negative 3 is plus 5x. 21 divided by negative 3 is minus 7. And we have a match between the front and the back. You bring down the x, bring down the minus 3. So now that I'm looking at this, it does look like we have all of these with a negative in the middle. So I'm going to do one more. I fibbed to you. We're going to make this up. 6x squared plus 25x plus 21. So there's nothing in common to factor out. 6 times 21 is 126. What multiplies to positive 126 and adds to positive 25? Okay, 1 and 126, 2 and 63, 3 and 42, 4 won't go into it, 5 won't go into it, 6 and 21, 7 and 18. That would work. So it multiplies to positive, adds to a positive. They're both positive. So you'd have 6x squared plus 7x plus 18x plus 21. Okay, what's in common in the front two? Just an x. And when you divide x out of 6x squared plus 7x, you get 6x plus 7. What's in common between an 18x and a 21? 3. And 18x plus 21 divided by 3 is 6x plus 7. So there's a 6x plus 7 in common and an x plus 3. All right. So that's the end of the A times C method. And don't forget there were problems in the description below that have full solutions with them so that you can practice. And that's the end of the factoring series.